Hello, everyone. Good morning. I hope you've had a great week. Welcome to another Airframes class. Today, we're going to be talking about landing gear retraction systems. I'm going to need you to pay close attention because there's a lot of useful information in this video. The picture that we're seeing here is of a gear retraction, or gear swing that's happening. There's several reasons why we would need to do a gear swing, and I guess all of them could be wrapped up in safety. We want a situation whereby when the pilot does choose to retract, the gear does retract so that you don't exceed the maximum speed that you can with your landing gears extended. Even more importantly, when they come into land, you want the landing gears to be able to extend so that they don't belly flop. Okay. The topics that we're going to cover are retractable gear system, the selector knob that we use to actually select gear up or gear down. We're going to talk about the actual locking mechanisms. So there's going to be an up lock when the gear retracts back into the bay, it's going to lock. And we're going to talk about how it locks when it comes back down, and the extra features like the over center, as well as some pins that we put in to basically ensure that when it's locked down, it is locked down. Okay, let's go ahead and learn more about retractable gear systems. I guess the contrast between the retractable gear and a fixed or rigid gear will be that the retractable landing gear system provides the advantage of having a more streamlined airframe, and which leads to greater efficiency in flight, less fuel consumption because of the lower form drag or parasitic drag that is present. In a fixed system, the gear is extended throughout from the takeoff to the last phase of flight. However, this retractable system has one little drawback, and that's because with a retractable system, it becomes necessary to have an emergency system for extending and locking the gear down in position in the event of a failure of the primary or normal system. So this is very logical because now you have the gear retracted, which is good, you're more streamlined. But what about when you're coming in for landing and that system fails to be able to extend? We need to have an alternate system of extending the gear. The alternate system that we have, which is called the emergency gear extension system, works like this. It unlocks or releases the up lock mechanically or pneumatically, and the gear is then allowed to free fall. So the gear free falls into that down position, gets into the down lock and the over center, and now it's safe for us to land, and then we can go into maintenance to figure out what really went wrong and how to fix it. Selector lever. A selector lever is used to command either the left gear, right gear, or nose gear into that up or down position, including lock. So when we select it up, it's going to retract the gear and basically make sure that it comes into lock. The selector is shaped like a small wheel that's attached to like a rod or a lever. The shape should actually remind the operator of an aircraft tire, so it's easy and very intuitive to remember. We're going to talk about some locks, up locks, down locks, but let's look at inspection. Inspection of the system actually depends on what type of retraction system is installed on the aircraft. The three most common systems we have are hydraulic, mechanical, and electrical. This is important to remember. We'll talk about sensors and switches that basically help the airplane coordinate what safety features to incorporate based on the current status of the airplane. What I mean by that is the weight on wheel switch, as well as squat switches. So we'll talk about up limits and down limits. So that basically tells you if the gear is up or if the gear is down. And then we'll also talk about squat switches, which tell you if the airplane is in the air or if it actually is on the ground, because it's possible for the gear to be extended, but the airplane is still airborne, right? And we will have situations like that. So the airplane's flight management system needs to be able to decide what should be allowed to happen, and that's what also gives us some indications like warning horns, warning lights when we're trying to do something that's unsafe. All right, there's a bunch of videos here that we are going to watch.
To make the landing gear work, we use many different systems on the airplane, including the Common Core system, the remote power distribution system, the landing gear system, the hydraulics function running on the Common Core system, the hydraulics system itself, and all of these systems have to work together to allow the gear to be extended and retracted. Well, I would say this is probably the first time we've ever swung landing gear with about 4 million lines of computer code. The benefit of doing this is we have extend and retract and control by wire on our landing gear system, which is lighter and more efficient from an airplane perspective. Gear swing is one of the big milestones in the build of the airplane because it proves so many of the different systems and it proves their build. All those systems have to work together at the same time. This is a beautiful gear swing.
Gear down. Coming down.
There are two types of lizard or reptilian.
1, 2, 3. No, don't bump yet. Is the handle all the way down?
What's that?
Is yours long?
Handle down. Say again, Carl?
Is the handle all the way down?
Your handle's all the way down. Yeah.
Okay, alright. Did yours lock? No. Nope. Okay, go ahead and pump it.
Okay, there should be locked now. I heard two clicks.
Yep, they're both locked. And Chuck, if you want to go ahead and lock, put them in positive lock.
We'll come back to them at some point. Okay, so we have, obviously not all airplanes have retractable landing gear, but when we have retractable landing gear in modern aircraft, it gives us an added advantage of having less noise and being more aerodynamic and being able to travel faster. It basically reduces parasitic drag, a specific type of parasitic drag which falls under form drag. in high-speed aircraft operation. Right? If you remember, we talked about induced drag and parasitic drag. The layman's definition for it is induced drag is any drag that we can't do without. Basically, it's drag that comes from the production of lift, while parasitic drag is things like interference drag, form drag, skin friction drag, wave drag, etc. So the type of drag that would occur if we didn't have retractable landing gear will fall under form drag primarily. So there are different methods of retracting the gear, and these include mechanical methods, which would have cables, rods, and linkages that physically move, etc. We have electrical systems, which will have electrically driven motors. We have hydraulic systems, which will have actuators and motors. Hydraulic systems are very popular for landing gear retraction because of the amount of power that they deliver. We also have emergency extension systems or free fall system. Let's take electrical retraction as a first example. An electrical motor is used to convert electrical energy into rotary motion. So the motor turns a reduction gearbox to decrease speed and increase the force of rotation. So that gearbox is what helps us to basically change that ratio of how much torque we'll actually get from the system. This will also change the rotary motion at a reduced speed to a push-pull movement. Linkages will also be used to connect the push-pull movement to the landing gear struts. Some aircraft will use chain drive to extend or retract the gear system. In the case of hydraulic systems, hydraulic actuating cylinders convert hydraulic pressure into a mechanical force. The selector valves, which is a selector valve that you can move up and down, the selector controls the actual valves that allow where the fluid is going to flow and where the pressure is going to be acting. So the selector valves direct the fluid flow to retract or extend the gear. We have sequencing valves that ensure that components operate at a certain time in a certain sequence, as the name implies.
All right, this now brings us to a quick quiz. What is the role of the sequencing valve? One option says it makes sure left hand, right hand nose doors open and close simultaneously. Let's see if that's the answer. Not really. Okay, let's try it again. It determines the correct order of door, gear, and lock movement. Or it ensures the nose gear goes up before the main gear. So as we discussed, it determines the correct order of the door opening, I guess first the up lock, or whatever lock is holding it, the door opening, the gear being released, etc. Let's check. Correct.
So obviously you want the doors to start getting into gear and moving before the landing gear begins to retract, right? So if you have a scenario whereby you're trying to release the gear and the doors are still closed, you can see how that could be a problem. We have shuttle valves that provide a secondary passage. So this is like an alternate route for extension in an emergency. And all this is done through tubing and hoses, hydraulic tubes and hydraulic lines. In hydraulic retraction, most systems today actually use a hydraulic powered pack containing a hydraulic reservoir, which is just a fancy name for a tank where we store hydraulic fluid momentarily. A reversible electric motor that is electric motor driven hydraulic pump. So we get a hydraulic pump that's driven by an electric motor. We have some pressure switches and some valves. So it's not a really complex system, and we'll hopefully by the end of this lecture you have a better understanding of how hydraulic retraction works. Hydraulic pressure is routed to either side of the piston in a hydraulic actuator. This actuator is connected to the gear to either raise or lower it. The pressure switches will stop the flow of fluid by turning off the motor. So we need a pressure switch to tell us at what point we've achieved success, and we need to stop applying that force. So this is a simple picture here. This is that reservoir tank that we talked about. The blue shows the return line for the fluid. And you can see that there's a piston there, right? So that piston is pushed up and we have a return flow. The first flow that we have is the hydraulic fluid supply. So it comes from this reservoir tank. It's going to come here. There's going to be one check valve here. The check valve is going to make sure that, fluid can only flow in one direction. So it'll flow in through the pump. And that is an electrically driven pump that basically works, and there's another check valve on the other side which prevents the fluid from flowing back into the pump. So that pump is going to basically pump into the other side of the piston, which will be acting as that hydraulic pressure, right? So in this configuration, you can see that pump leads straight to the pressure side. In this example here, you can see that there's been a switch, the selector valve. So the selector valve is what's going to decide which way the pressure is going to be acting and which way the motion is going to be. If you look from here, you see the pressure acting from the top of this cylinder. So it's going to basically push the piston down. So it's going to bring this kind of down motion. By changing the configuration of this selector valve here, you can see that the motion is now facing upwards. So in this case, you have a pump, you have check valve, fluid passes through the pump, comes out at the other side, there's another check valve, and this basically acts as a pressure that's pushing the fluid now from here, and we have the return that's basically going to be returned back into the reservoir. So as you can see in this position, you have gear down position, you have the pressure coming from the top, pushing that piston down on the right main gear, as well as the left main gear, as well as the nose. We do have some restrictors here. We have a pressure switch and a thermal relief valve. This system is the alternate system where you have a free fall control, but we'll get into that in more detail shortly. This is the opposite. This is when you are applying pressure from the bottom of the piston and basically forcing that piston up to basically create that upward motion. So what is that gear selector? The gear selector is located in the flight deck, in the flight compartment, and it consists of a lever that has a roundish knob. I shouldn't say a knob. It's more like a wheel. Yeah. So it has a wheel that you can kind of hold that wheel and move up or down. So it consists of a lever that has a round handle. The handle resembles the wheel of a tire. It actually has some portions that look like a thread. I think they're pretty cool. Anyway, the selector has basically three positions that it could be in. It could be in the up position, which is used to select the wheels to go up. It could be in the down position, which is used to select the landing gear to extend. And it has a center position. Basically, after you select one, it's going to return back to that neutral. If you select up, you close that switch. We'll talk a little bit more about the switch. And then now you're back into your neutral position. So the center position, when the gear completes the selected travel, the levers will return back to the neutral centralized position. So gear position lights are also an additional safety feature. So if you're flying the airplane or basically doing a test, you would want to see, you would want some kind of visual indication, because from the flight deck, you may not be able to see the landing gear and know if it's really, if the command that you've selected, i.e. gear up or gear down, has been completed. So we have gear position indicators in forms of lights that tell us what the condition of our gear currently is. So we have it down and lock. When the gear is extended down and is locked in position, you get a green light. Obviously, green would be a good light. When you're coming in for landing, you want to make sure that you're going to see that green light so that you can come in on approach. When you have the door open, or when you have your landing gear door open, you get an amber light. So you want to know that you have your landing gear open, or your landing gear door open. Or if you don't want it open, you still want to be able to get that indication. And so amber, important. When the gear is in transition, so that means you've selected gear up, but the process is still happening, you see a red light. You see a red light come on, right? And so you need to remember that red light. We also have a gear up and lock. So once the gear has retracted and is up and is locked and everything is good, you get no lights. That's kind of the new ideology in aviation. We want to go with basically, if everything is fine, you don't want to stress out the pilots. It's going to be blank. That means everything is good, right? Nothing to worry about. So this is what the selector actually looks like. It has a lock release, and this is that wheel that we talked about, the selector. So you can grab this with your arm, lift it up, and this would be you selecting the gear to come up. So that means the gear is probably down and you're trying to select the gear to come up because you've become airborne and now you want to retract your landing gear up. So when you select that, while it's in transition, remember you're going to get a red light while that is still happening. Once it's up and locked, then you get no more lights. The opposite is true when you're coming in for a landing. You put the gear, you take this lever, you put it in the down position. It's going to momentarily obviously return back to neutral, but you basically close the circuitry that will command the gear to come down. When it's in transition, it's going to show a red light, as you can see right here. And once it's fully down and it's locked in position using the down locks, this is where you would get the green lights. So if you notice, you have 3 green lights. One of them will be for nose, and then the other 2 would be for the left and the right gear. You can also see some annunciators here. So this would be for the left door, this would be for the right door, and this would be for the doors at the nose landing gear. So you have left, nose, right, left, nose, right, to give you indications if you have green, if you have red, or if you have amber. Okay, so amber is for door, open position. Green is for everything is down and locked. And red is for gear not up locked or down locked. So that means it's still in the process of completing your command. So this is the gear selector. Landing gear positions and warning. Landing gear down and lock. You have light circuits. So we're going to be looking at some of that circuitry. But let's first go through what happens verbally. So power travels from the landing gear indication circuit breaker to each down lock switch for the left hand side, the right hand side, and as well as the nose gear. So when the wheels are not down and locked, the switch is going to be open. So when the switch is open, it means that there's no, it's not a complete system. So it's broken. So you have power coming from one side, but you don't have a complete circuit because you're somewhere in between. It's open and you're not able to make ground. so you won't get an indication. When the wheels are down and locked, the switch is closed. So that means the circuitry is complete, and now it can go through from power, go through the light bulb, and basically go down back into ground. Obviously, there's relays in between that help you to actuate that switch. When the landing gear is down and locked, power travels to the applicable gear light. The gear light illuminates green to indicate that the landing gear is locked. So you get 3 green. This indicates that the left, the right, and the nose are locked. So this is what the circuitry looks like. This is your power source, and you basically have that. Now that power source comes all the way here. This system, if you see, it splits off into 3. This is one system, another system that's getting power, and the final system. So one of them, this one, this represents the left main gear and the lights. This represents the nose gear and the lights, and this represents the right main gear. So when you've selected your down position and everything is completed, you're going to get 3 green. But there's a process that has to happen for that. So once you select the gear down, and you're basically going to close that switch. So the switch position was somewhere here before. Now you're going to close that switch, and that's going to basically allow the circuitry for the left main gear to be complete. Scroll down, you see that you have the light, the green light, once it's down and locked. Okay. You look at the one for the nose, so you have electrical power coming from the main bus. It comes out this way. That switch for the nose will basically, if you have a complete closed circuitry, then you get the light for the nose, and the right gear is the same. So you have a lamp, a 2.8 amp lamp that basically illuminates to let you know that the gear is down and locked. So these are the ground for the systems, obviously, but they won't be able to be complete until that switch is closed. Okay, now let's talk about landing gear up locks. So up locks, this locks the landing gear in the up position. So the landing gear is kept up ideally by hydraulic pressure, but you can lock it up. There is a lock that's used to lock it up. The down lock is used when the landing gear is fully down and extended, and this basically prevents accidental collapse on the landing gear while you're on the ground, right? So you would hate to be taxiing along after a good flight and then just have your landing gear buckled in. So we have a down lock that basically ensures that it's locked. We also have something called an over-center linkage. So an over-center linkage is like an elbow. It's where instead of just locking into position, it actually goes over center. So it acts as an additional safety mechanism to basically make sure that even if the airplane lands with some side loading, it doesn't accidentally shake out and come out from that lock position once you've locked it. So that's the over center linkage. The linkage that travels beyond the center. So it goes a little bit further, and it's a method of locking the gear down. It's an additional method of ensuring that the gear stays locked down. We have ground lock pins that are inserted into the landing gear mechanism to prevent the retraction of the gear after you've shut down the engine. So you have additional ground locks that these are pins that basically are going to go through a certain orifice, and basically that's going to act as a means to prevent the landing gear from retracting once you're on the ground. The only time you would leave this in is maybe when you're going for like a maintenance run. You're going to run the aircraft engines, and you know that there's no way that you're actually going to be flying the airplane, so you don't have to worry about that. You may leave them in, but otherwise, whenever you dispatch the aircraft, you want to make sure that you take out these ground locks so that the airplane is able to retract the gear and have a good flight. There's another video here that we're going to watch in a second there now.
Okay, this now brings us to another quick quiz. This one's heavily loaded. The question is, what are the safety features of the landing gear when the aircraft is on the hangar floor for maintenance? So this question is specifically asking us when the aircraft is landed, is on the ground, is in the hangar, what are the safety features that we have? So the options are ground lock pins that are inserted, safety switches, linkage over center mechanisms engaged, gear down lock, as well as all of the above. So the correct, let's see if we choose all of the above. Yes. So let's take a quick look. So the ground lock pins are the movable pins with the red streamers that when inserted prevent the gear from folding. Our safety switches are also important. These safety switches lock the gear selector handle and remove power to the retraction system. So this is important. The safety switches lock the gear selector handle and remove power to the retraction system. The linkage over center. The over center position makes it more unlikely that the gear will accidentally or incidentally come out of that lock position without a command to do so. Okay, so there we are.
Regards to up locks. So this is the up lock. That is where the gear actually goes into lock, and this is the roller that's attached to the landing gear system that actually goes and sits inside that hook when you retract the landing gear fully. These are ground locks, and these are the pins. They'll have a streamer that will be visible to anyone operating or doing a walk around, and these will say remove before flight. So you can see the insertions of these pins. This was an accident that happened. It's rumored that this was as a result of a hydraulic system check, and the pins had not been installed in the gear. So,
all right. Quick question about some lights. So I know we talked about the lights that we get when the door is open. We get that amber light, right? When the landing gear annunciator panel shows a red light, when any gear is still in motion and has not completely locked in the desired position. Is the statement correct or is it false? The landing gear annunciator panel shows a red light when any gear is still in motion and has not completely locked in the desired position. I'm going to go for true. That's correct.
This was an accidental retraction, apparently.
Now, I just mentioned this. The color of the warning light that appears when the respective gear door is open is dash. So the correct answer here would be, drum roll, amber. Hooray. You would also be correct if you selected yellow, but amber is the color.
All right, let's talk about landing gear components. We have some components, systems, I guess, checks that help us to keep the landing gear operating functionally. So we have a nose wheel centering. This centers the nose wheel after takeoff. So after takeoff, you want to make sure that that the nose wheel is centered. So we have something called nose wheel centering feature. We have drag struts or drag braces. The drag braces, they basically support the aircraft in the forward and aft direction. So this would be forward. If I was sitting in the captain's seat facing forward, the drag struts basically provide that forward and aft support. Conversely, we have side supports or side struts or side brace, and this supports the landing gear in the sideways orientation. Quick addition is that what this side strut attaches to where we actually have the gear down lock mechanism, right? So we have the down lock. It's is also carried by this side brace. This now brings us to torque links. Torque links are like a scissor link. They basically attach the lower cylinder and the gear, the inner cylinder and the outer cylinder to the gear. So it's like a scissor link that basically allows it to be centered, but allows the outer cylinder and the inner cylinder to move relative to one another.
And these are the torsion links or scissor links. So they're called torsion links or scissor links. Same name would apply.
So the torque links or scissor links connect the axle assembly to the main gear strut. This keeps the wheel aligned with the main strut, but still allows it to be able to move up and down. We have sequencing valves, and basically, like I mentioned earlier, the sequencing valves determine the sequence of events. So, i.e., you could have doors open, and then you want the gear to be unlocked from that up lock that's holding it. You want the gear to, go into gear up, and then the doors to close. So this would be for returning the gear back into the bay. So this is a retraction sequence actually. So you want the doors to open up so that there's a place for the gear to go. You want the gear down lock to be disengaged, so the gear is unlocked from that down lock system that's holding it. You want the gear to be pushed by hydraulic pressure and retracted up, and then you want the gears to close. And this is a sequence that you're going to be watching when you look at those videos. So this right here, this is your drag brace, right? So this is the aircraft, and the aircraft is, this is us facing forward. This is your left main gear that is shown. Obviously, there's one wheel on this side, but there's also going to be one wheel on the side. This wheel is not shown just so that we can see the brake system. We can see the axle and that axle sleeve. You can see the shock struts, and then you can see the up-lock roller. So the up-lock roller is going to be located here, and when the gear is retracted up, it's going to go into this up-lock hook here and stay there in that J-hook, right? What I said before, I said this is the side strut. So this is a sideways view, and this basically supports the gear to the side because the gear is going to retract in on its side, right? So the gear is not, the main gear is going to retract into the landing gear bay in the belly of the airplane. So this is our side strut right here, our side brace. And as I mentioned earlier, it carries this important down lock mechanism. We have the doors. Obviously, the landing gear is a very important piece, and as such, it will be attached to a strong point, which is going to be the rear spar attachment. Okay, so this is the landing gear rear trunnion support beam, and then we have the rear spar up here. Okay, so this is the torsion link that I talked about. The torsion link basically attaches the axle point to the upper gear mechanism. It allows it allows for some movement, but it makes sure that it keeps it centered so that the two cylinders are centered one to another. This is another picture here showing that. So that's the up lock roller that basically goes and gets locked into that up lock mechanism that we showed over here. The up lock mechanism, the receptacle. So you can see our torsion links right there. You can see our shock strut, the drag brace that basically supports that forward and aft support to the gear. You can see the side brace, and the side brace carries that down lock roller.
Okay, so quickly, just to clarify the difference between, I guess, the function of that scissor link and what the centering cam is. So the centering cam is specifically for the nose wheel, and it is designed so that the nose wheel is centered for retraction and extension. Right, so we want to ensure that the nose wheel is centered for retraction and extension of the gear itself. The scissor links basically allow some movement up and down, but it's not about really retracting the gear, and that's why in some towing operations we actually need to disconnect that scissor link to be able to allow for that rotation, so that we can tow the aircraft at greater angles than the torque link would allow us to do. Okay, so that's important that we know that. I mean, how does an oleo or shock strut actually protect the aircraft from shocks? So basically it absorbs and dissipates that shock loading internally. So this is also an important feature. We'll be talking more about oleo struts in the following lecture. With regards to the ground lock, since we can kind of see that ground lock mechanism and where the hole is, where the pins go, the reason that we have that ground lock is basically to keep the landing gear safe from retracting during maintenance practices. Right, so we want to keep it safe from retracting during ground maintenance operations. And last but not least, we talked about the WOW switch. I know it's a pretty cool name, but just remember that this is the switch or the system that basically provides information to other relevant aircraft systems and tells them when the aircraft is on the ground or when it's off the ground. Things like ground spoilers, we want to know when to actuate them, and the WOW switch, the weight on wheel switch. Okay.
So carries the hook assembly. So this is where the down lock roller would go and sit in. This now brings us to the squat switch, or the weight on wheels. So we have a safety switch. This safety switch prevents gear retraction when on the ground, because this could be an undesirable time to have the gears retract momentarily. Methods. We have the lock gear handle should be in neutral position. So that's why we have an up selection. On the selector, we have a down and we have a neutral. It always comes back to neutral, and there's a lock there. If you remember, there's a red lock that you have to kind of push in to get that lever to be able to move. Then we have the isolates the retracting system. So we have an isolation valve that basically makes sure that certain conditions have to be met for that to happen, for that system to become activated or become live. We have a way to remove electrical or hydraulic power to the system as well. Located on one or more of the landing gear systems, we have this the safety switch that determines if the oleo is extended and compressed. So we have the squats switch. So the wow switch, the weight on wheel switch, they provide information to other important aircraft systems like your thrust reversers, your avionics systems, your brake anti-skid, some flight controls, your ground spoilers, so that they know when to actuate. If they don't feel that the aircraft is on the ground, it would be unfortunate to release ground spoilers, because this would probably give you a really hard landing, as you would lose altitude, because then it wouldn't be acting as a ground spoiler. In that case, it would be acting as an air brake to help you lose altitude rapidly, and that's not what you want to do when you're coming in to land. So there's several important systems that you want to have. You want to know when the anti-skid wants to know that the aircraft is actually on the ground before it kicks in, etc. And as well as for pressurization of the entire aircraft, right? This now brings us to the Piper Seminole design. So this is an aircraft that's usually used for training, and it has some of its own special features in terms of its design. So we have the landing gear squat switch. So the landing gear squat switch circuit, when you select the gear up, the power is going to travel from the hydraulic pump of the landing gear control CB. The gear selector, once you have gear up, this will cause you to basically close the retract circuit. If you have gear down, this will close the to extend circuit. The gear up relay is going to be decay 303, kilo 303. You'll see that, just keep that relay in mind. That's for the gear up. To the hydraulic pressure limit switch, you want to get pressures that are greater than 1800 psi. The switch will open and the pumps will stop. When the pressure is less than 200 to 400, the switch will close. The oleo is extended, then the circuit is going to be open. If the oleo is compressed, then the circuit is closed. So if you want to, so that's how that weight on wheels, or that squat switch basically works. So this will give us a good indication too. A closed circuit, we have a gear up relay that is also already closed. We have a hydraulic pump circuit. The power travels from the hydraulic pump power CB. Same thing happens to the up relay. The up relay needs gear selected up and weight on wheel switch to close. Right? So you have to select the gear up, and to get that weight on wheel switch before the up relay is going to close, which will complete the circuitry and make the system operate. If the up relay circuit is complete, then power travels to the hydraulic pump. Hydraulic pressure will provide pressure to move the gear. When the gear is up and locked, you have a hydraulic pressure. Once the hydraulic pressure exceeds 1800 psi, the hydraulic pressure limit switch will open and the pumps will shut off. So that's where if you remember, I mentioned us having limit switches, and that's quite different from the weight on wheel switch. So the limit switches tell us if the gear is up, retracted, or extended, but it doesn't necessarily tell us if the aircraft is on the ground or if the aircraft is airborne. So when you select the gear down, you have a different circuitry. The landing gear down relay circuit, power travels from the hydraulic pump into the control CB to the gear selector. Once you're in the gear up, this will close that retract circuit. Once you select gear down, this will close the extend circuit. So you want to select the gear down in this case. This goes down to a different relay for gear down. If you remember, for gear up, it was K303. Now it's K302. So the landing gear down lock switches. The landing gear is not locked down, the circuit will be closed. When the landing gear is locked down, the circuit will be open and then the pump will shut off. The closed circuit, the down relay will become closed. So that is the condition that is required. So let's have a quick look at what actually happens. So we have that's that K303 relay that I was talking about. So you have a power source that's coming from the buzzer and you have a control. So the main power is coming from here, going through the system. Now, depending on the condition of your control switch, if you select up or down, that's what's going to activate that. So this is, if you select up, you're going to basically energize this relay, which is going to close the circuitry by pulling that down. Now, once it's closed, then you now have a complete system that goes around this way and then comes here and can make ground. So it goes through a hydraulic pump and now can basically complete the ground circuitry, right? The same is true for the other system, which is for when you select the system, the landing gear selector to down. So remember, this is the landing gear selector and it looks like a wheel. When you select it to down, you always still have that power. The power comes from here. It can actually bypass this relay and come all the way here. If you have the selector selected to the down position, it will activate the relay K302 for down, and that would basically close that down circuitry and also give you that hydraulic pump that would allow the gear to move. So now we want to look at some warning indications that we could possibly have when we're operating the aircraft. So power travels from the gear horn circuit breaker through a switch, a squat switch. The squat switch closed with weight on wheels. To select the gear selector lever to the up position, you have a circuit that is closed. So you're going to get that horn when you are trying to do something that's not designed. Let's look at the circuitry. So if you have no power to the hydraulic, if you basically get that horn, it'll also ensure that it does not release hydraulic pump.
Okay, so one quick example of this is if as an aircraft maintenance engineer, a pilot reports that he gets a loud horn in flight when he puts the throttle to idle. So, you know, what could possibly be causing this? What kind of troubleshooting would you do? Shy of going to the fault isolation manual, you should possibly suspect that the throttle and the landing gear position are in disagreement, right? So if you hear that horn, if he's getting that loud horn in flight when he tries to put the throttle to idle, it basically shows that there's a disagreement between the throttle position and the landing gear position.
Hydraulic pump won't come on, so you won't get any action.
Okay, that pretty much wraps it up for us. Thank you for paying attention. If you look in your announcement section, I'm going to be dropping a link to a gamified Kahoot where you can put some of your knowledge to test. That would be on Saturday, so just keep an eye out for that. But otherwise, thank you, and I'll see you next week. If you have any questions, just email them to me directly. Or you also have my phone number. If you need to reach me for some reason, please feel free to do so. Otherwise, everyone, it's Friday. Have an awesome weekend, and I will see you when next we see. Take care.